Sounds are on clear. Can you hear me clear and loud, everyone? Yes or no?
Yes, sir.
Is it better now? No.
Yes, sir.
Okay. Now it should be fine. Okay. All right, welcome. Is it possible to reduce the number of case studies? No. Why do you need to reduce number of case studies? Okay. All right, let's discuss about case studies once we finish the lecture. Now, let me begin with, let me our regular lecture, which is now today is lecture 6. All right. As I said, so this is the beginning of week 5. This is not week 6. I'm receiving some more questions. So is it possible to increase the assessment and remove the exam? Look, so regarding the final exam, well, we don't know yet how we structure the final exam. It's a bit still under discussion. I don't see the link of the video recorded from last lecture. It's not been uploaded yet. I will try to upload today because it's a big file. I need some alternative arrangement to upload the lecture. Okay. Exam removed. We haven't decided yet how we can organize the exams because things are changing every week and it has to be consistent with other units. In other unit, exam assessment reduced to 35%. Let me see what can I do. Has the group project thing uploaded yet? Not yet. So we need to form the groups first. Group project will be uploaded on week 7 because a significant part of group project is related to the lecture. So you need to tools and techniques of the project management, then you can start working on the group project. It will be useless if I upload the questions now. Other exams has been removed. Which units? I mean, it depends on every unit is acting on its own. So if they have options to reduce exam or remove exam, they are doing it. If we don't have options, I mean, we have to keep it. All right, it's a is case study done in group, individual submission. This is individual submission. Good morning, good afternoon. Case studies you can discuss with your, you can discuss with someone. You can sit down. You can group study, but the submission is your individual submission. Any other questions? So we'll see how we can organize exams. It can be a reduced scale. It can be multiple choice. It can be any format. So we will decide from the School of Engineering what is the best format to take the final exam. Okay. Can you start now? Multiple choice will be the worst way of examination. Okay. Is there any template to follow for the case study, or do we just answer the questions? You just need to answer the questions. It's up to you. There's no template. All right. So Please feel free to ask any questions that you may have. I will come back to the chat window again and read all the questions you have. Now, is there any template to follow? No, so there is no template. You have to be really professional in all your submission, right? So there are 2 questions, 5 marks for the total assignment, 2.5 each. Now, neat and tidy presentation, how you organize, it's all up to you. Okay. Do we need to give references for each questions? No. Do we need to put cover page for the assignment? No. Make sure that you put your name and student number on top of the assignment page. Okay, now let's begin our lecture. Now, this is week 5. This is the beginning of week 5. The new online academic calendar. We are now starting lecture 6 just because we got 2 extra days just before the university before we stop learning and teaching activities. We got the extra 2 days, so we were, you know, we are ahead of the academic calendar. But this is lecture 6. This is lecture 6 here. That's right. But this is the beginning of week 5. We got 2 extra days before university closed on the 18th of March. I think it was 18th or 16th of March, whatever. We finished lecture, 1 additional lecture, and the university started again from Monday. So we got the extra 1 week, extra 1 day to, you know, that's why we're now in lecture 6. So this is the beginning of week 5, day 1, week 5. Now we started from introduction, then we covered on the strategy part, organization structure, then how to define a project estimation, network diagrams. Then today we will focus on the resources and cost, how we can schedule the resource and cost. This is closely related to the project network diagram, how we can optimize the existing resource, whatever we have in terms of time. It can be in terms of time, in terms of human power, and also in terms of money. Then from in the next week, I think we'll cover how we can reduce the project duration resources. All right. So what are the resources and priorities? So if you look, if you can recall from the project network diagram, we have we can identify the critical path. We can identify the project duration from the project network diagram. That's all pretty good. We can well structure before even the project started. We can take leverage of the project network diagram as how we want to proceed the activities. The activities come from the work breakdown structure. This is the lowest element of work breakdown structure. We know exactly what we have to do. That helps us informing the project network diagram. That's all pretty good. That's fine. But we don't consider the resources we have when we develop the project network diagram. I mean, we can have a rough estimate of the total duration of the project, but that is being developed without considering how much resources we have to carry out all the activities as we planned in the project network diagram. Okay, so when it comes to allocating resources, we can see that the project network diagram will be changing. In the upcoming slides, we'll discuss some examples and more discussion on how we are restricted to the resources and how the project network diagram will change due to the shortage of resources. So the network diagrams are not as scheduled because resources has not. That means this is the project network diagram that we have in place. This is the first skeleton of the beginning step of the project. And when we don't have a schedule of resources yet, we don't know which activity we can carry on, which activity can start as planned in the project network diagram. It goes same for the budget as well. So cost estimate are not a budget until they have been time phased. So we need to time phase. That means look into every activity, how much time it will take. So there are two parts of the lecture. This is the first part, how we can allocate resource, step one. Step two is building the time phased budget, how we can relate that to time phased budget. So cost estimation, this is the first step, obviously, that helps us in identifying the overall cost of the project. But when we start building the time phased budget, we will get to know a lot more about each activity, how much money we need for each of those activities. So two aspects of the lecture today. One is how we can schedule the resources and how we can build a time phased budget. So if we look into the next slide, you can see that at every step, there is obviously a risk assessment process. It's a continuous process, such as an iterative process for every step we take, starting from the scope and WBS. Then we move on to develop project network diagram. Then we start allocating the resources and cost scheduling. Then the master plan. Every single step, there should be a risk assessment involved in moving forward. That means scope and from scope and WBS, when we start developing the project network, then from project network to resource scheduling. So this can change a lot of the project network diagram, in a sense that a lot of the activities that were not critical, once we allocate the resource, those activities will become critical. The critical path that we initially identified from the project network diagram may not be a critical path anymore. So we'll have a new critical path depending on the restricted resource and cost. Okay, so the entire project diagram, network diagram can change. There will be more criticalities. Depending on what resource we have. So there are some limiting assumptions that we must consider before we develop the resource scheduling process. All right. So in the process, there are a few different ways that we do. So one very important one, first of all, resource smoothing or leveling process. This is a very basic, you all should have some understanding of what is a smoothing operation or leveling operation. That means we avoid all the peaks in allocating the resource. So if we have multiple tasks and the resource demand is something like this, all right, we have the option to reduce the peak resource demand in each of the time phase, or each week or each day or each month, whatever the time phase is. We can level it, we can smooth it. So it helps us in even out the varying demand or resource by using the slack. Obviously, we'll be taking advantage of the slack we have from the project network diagram. The most important contribution of the project network diagram so far is it gives us the indication of how much slack we have and what are the activities that we can play with to smoothing or leveling the resource demand within the project network diagram. Then resource constraint scheduling is for the duration of the project, it may be increased by delaying the late start of some of its activities. So resource constraint scheduling, so that means the entire duration of the project, it can be extended once we do the final resource, once the resource scheduling is done. We will see that the entire duration of the project will be increased. There are some types of error that what are the project Why we cannot execute the initial project network diagram that we developed. What are the background reasons? If you look carefully in the project network diagram, all right, that's it gives us a good indication of entire duration and the free and the total slack. This is very important to know. But once we start implementing the task, we will see that there are some constraints. We say, for example, technical or logical constraint. That means we cannot. We need to maintain the sequence of activities. We cannot start building the prototype before the design is complete. So this is a type of technical or logic constraint. We need to maintain the sequence of operation to finish the project on time. Constraints, activities such as that cannot occur in parallel or that can affected by the contractual or environmental conditions. So these can be physical constraints. There can be resource constraints. Say, for example, people, materials, and equipment. If we are developing a software for an IT company, we have 3 programmers. So if we exactly follow the project network diagram, there can be cases like where we need 5 programmers at a time to start and finish as we plan in the initial project network diagram. So that because of the limited resource, that cannot happen. So we need to look into what resources we have. It can be absence, shortage, some interrelationship. It can be, it is based on mostly on people, materials, and equipment. Access to resources. Can we start as we plan from the project network diagram? So a number of constraints. If you try to implement the original project network diagram, we will face these problems. These are really embedded into the project. It's not uncommon. It's very common. But as a project engineer, as a project manager, you need to be able to identify what constraints you have and how you can best optimize within existing resource. So if we, these are some of the examples, as I said. So say, for example, we cannot start coding until we finish the design process. Even though the design engineer is sitting idle, we cannot start the we need to follow the sequence of operation in every single project, right? So that's one type of a technical constraints. There can be resource constraints. Say, for example, for the multiple or parallel activities that we have. Can you repeat the first constraint? So the very first one is a technical. That means we need to follow proper procedure. Say, for example, in a civil engineering construction project, if in domestic housing, we need from the start concrete foundation, then framing, then roof, then completion of the project. So we cannot have, even though I have manpower and resource to finish the roof, to start the roofing process, we cannot do it until we have the foundation and framing done. So this is a type of technical constraint. We need to follow the sequence of working procedure. Even though we have here, this cannot be loaded onto the project network diagram to do it as soon as we have the resource, let's do the roofing first, and then we'll do foundation later. No, it cannot happen. So we need to follow a sequence of operation in any project, right? So that means it depends. That's right. So that means it depends on the previous steps. So we cannot, even though we have the resource, we cannot start it. So we need the very first constraint is we need to follow the sequence of operation, as this is one type of a technical constraint. There can be resource constraint, such as the multiple activities or the parallel activities. In terms of the manpower, we have limited manpower, but that means we cannot operate all activities on parallel basis. right? So this is one of the resource constraint. We are really constrained by the human power we have. So how can we take care of all this? So if you look into, if you go to the next slide, you can see the classification of problems in terms of, this is what? This is classification of scheduling problem. So once we have the project network, then we start scheduling the resource. There can be two types of problems we face in moving forward. The first one is the time constraint, and the second one, resource constraint. Time constraints are very simple. We cannot extend the time. No way. We really need to finish it on time. The amount of time we have, whatever resource it takes, time is fixed. Time cannot be changed in any sense. This is the time constraint project. Then the next resource constraint is resource constraint project. That means all resources are fixed. These include manpower, all right, human power, equipment, software, whatever we need to carry each activity from the project network diagram, but maybe time is flexible. We always need a trade-off between time and resource. There is always a trade-off. Which one is our most preference? Is it the time or the resource? If we need to save time, we need to sacrifice resource. If we need, if we're limited on resources, we need to sacrifice some time. The project will be elongated depending on how much resources we have. Now, so now let's move on. First of all, in the resource allocation method, there are some limiting assumptions that we consider. For example, splitting activities is not allowed. We cannot divide activity into multiple tasks. So if we have activity A, all right, we cannot literally do it like 1/3 of activity A, then this is 2/3, then this is the remaining section of activity A. So that means splitting each activity into multiple sections. This is not allowed. We cannot, once we start an activity, we must finish it. All right. Next one is the level of resources used for an activity cannot be changed. So if we need, say for example, if we need 3 civil engineers to complete activity A, that means 3, it cannot be changed. So it is already decided that we need a minimum of 3 civil engineers to complete a specific task. That cannot be changed. There are some risk assumptions. Say for example, activities with most pose the least risk. So very simple. The higher the slack is, the lower is the risk, right? Risk goes low and low. So that means we can focus on activities that has got the highest slack. Reduction of flexibility does not increase risk. So that means in the resource scheduling process, if we use the slack will be in some of the activities. So if the slack reduces, we are reducing the flexibility in the entire chain. So if we play with the amount of slack we have in each of the activity, slack goes down, then we are limited by reduction of the flexibility. That doesn't increase risk. So we are trading off with the amount of time we have, considering that risk remain same. We are not possibly increasing the risk by reducing the slack of any activity. The nature of an activity, easy or complex, does not increase risk. So these are the risk assumptions. That means in the optimization process for allocating resource, we consider that we are not imposing any additional risk due to reduction of the slack. So again, in the risk assumption, this is this is like assuming in the resource allocation process, no additional risk is imposed. Right? So that means we cannot take some extra risk, some additional risk due to the resource constraint that we have. So we will be playing with the slack we have, amount of slack in each activity that will help us in leveling or smoothing resource, minimizing the resource peak, such as at one time step we may need a very large amount of resource, and in the next step we may need, as compared to the previous step, we may need significantly lower number. So we can evenly distribute and level those peaks that will not impose any additional risk. The first assumption is activities with most slack. So this is very simple statement. If you look at the project network diagram, you can see there are some activities with, say for example, 15 days, 35 days of slack. So if I take 10 days of slack from out of 35, that will not pose any additional risk. All right? Or if I have two activities, one with 10 days slack, one with 20 days of slack. So the first statement says activities with most slack pose the least risk. So that means with highest amount of slack, 10, 20, 30, the higher the slack is, the lower is the risk related to that activity. All right. So if we are flexible with slack, there will be no effect in risk. I mean, in terms of the slack is identified to clearly, you know, mark the flexible zone, right? Which activity is really flexible, how much time we have in those activities. All right. So that means the total slack is identified in a way that if we play with that slack, that will not affect the risk. That's right. So it will have no additional risk, no effect on risk assessment if we take the slack or if we use the slack. All right. Then the second point is reduction of flexibility does not increase risk. That's all right. We've been discussing this. And the nature of activity, easy or complex, doesn't increase risk. So there will be some activities which are really, really complex. It requires, say, for example, you know, if I give you the most recent example of developing vaccination for COVID-19, there are some people working in the lab, a high risk zone with their protective suit and in the clean room. And once that work is being done, once the vaccine is being developed, that will go to the production line with some other people that will be at less risk, right? So the nature of the activity, whether it is easy or complex, does not increase the risk of the project. This is just the nature of activity. It can be easy, it can be complex, it can be really, really difficult. It can be, so that means the initial risk assessment does not increase on the type of activity we do in any projects. Okay, so in the time constraint project, as you can see, must be completed by an imposed date. We do not have any flexibility on the on the time. Whatever it takes, we have to allocate and must finish on time. It requires use of leveling technique that focus on balancing or smoothing resource demand. Obviously, we can play with the available resources we have and still carry on the balancing or smoothing process. An approach is use the positive slack or delaying non-critical activities. As I said, this is the most important contribution of the project network diagram. if we know exactly how much slack we have and which ones are the critical activities, we can use the positive slack or delaying the non-critical activities to manage the resource utilization over the duration of the project. There are some benefits, like the peak resource demand is always reduced. We'll see in the next slide how the peak is being reduced. Resource over the life of the project is reduced. Peak is reduced, very simple. So we are leveling the resource demand in each time step, resource over the life of the project. So that this means that we can, if we do a smoothing operation or leveling operation, we know exactly how much resource we need for each of those steps. We can, if we level it properly, that means we can still finish the project on time with the available resource we have. So that over the entire life of the project, we may not need any additional resource to still finish it on time. Then fluctuation of resource demand is minimized. If you look at the next slide here, this is a very simple illustration. You can consider anything in here. You can consider any civil construction, any mechanical projects that you can think of. It can be related to anything. So if you look at the time, so x in the x coordinate, we can see the number of weeks or the time zone, and then in the y coordinate, how much resource we need. Okay, so in any if we don't do smoothing operations, if you look at the slide here, so say for example from 0 to 2 or 0 to 4, this is the amount of resource we need. From 4 to 10, we need 2, 3, 4. Okay. Then from 10 to 16, we need this resource. From 16 to 24, we need this. If we plot it, if you look into here, as of in terms in the second diagram, all right. This is in terms of the number of resources we need during each time frame. So you can see that from 0 to 2, we need 2 units of resource. Then in the next time phase, from 4 to 10, there is a sudden peak. The resource demand increases in the next. What are the backholes? So these are, for example, developing a botanical garden, a civil construction project, right? So you need to dig some holes for plantation and some other purpose, or civil construction or foundation, whatever it is. So a typical example of the set of activity, how much resource you need. Okay. So then in the next step, you can see that the resource demand is really, really low. So you only have one backhoe needed during time from 10 to 16. So from here we can see we have the option to level. We have the option to take that one backhoe and remove it here and make it evenly distributed like this. All right. Then from 16 to 24, there is always a requirement of 3 backhoe during that time frame. So if we do the resource smoothing operation, we can start from we can take these 2 and make it 3 evenly distributed. This is the smoothing operation for, say for example, the civil construction project of building a new botanical garden. Very simple illustration. It can be applied to it can be applied to many different projects. So in simple word, we start with the low resource demand from here. Then we at any time we can make 3 backhoes. So these are limited by what is our maximum capacity, the amount of machine or equipment or human power we have. At any time we can make maximum 3 units or maximum 3 backhoes, 3 foundation. So that means we are limited by the amount of resource. So how can we smooth it or level it? Just a simple illustration. So this is a smoothing or leveling operation. So why we smooth 2 BH instead of 1 BH. There is no difference. There is no difference. No. These are for illustration purpose. These are for illustration purpose. There is no difference. So you can. It's up to you how you want to play with. Okay. Okay. In the resource demand leveling process, resource demand leveling techniques for time constrained project. Why is this smoothing required? Because we may have limited number of resources. If we need 3 civil engineers for foundation project, right? That means we have to continue the work with 3 civil engineers. In the previous example, we need, if we continue with 5 or 4 backhoe, we may need 5 civil engineers. We may not have that, so that's why we need to level it. We need to smooth it. Then there are some advantages, like the peak is always reduced, as we saw in the previous slide. This is smoothing operation is basic mathematical operations in any data analysis part. You all know that if you have a really rough curve, we can have the option to smooth it like this. All right, this is the mathematical operation. But when it comes to project management, we have the resource demand like this. Okay, so if we smooth it, that means we can take some activities off during that time frame 1, 2, 3, 4, 5, 6, shift it to the next time step. Then we'll have an evenly distributed resource demand during the entire duration of the projects. This is just to smooth, or at any time of the project, we are not overburdened with amount of activity or manpower or resource we need to finish the project. Fluctuation is always minimized. That's good. In terms of disadvantage, we have loss of that occurs from reducing slack. So how do we do the smoothing operation? We cannot do it as we like. Obviously, we need to look into the slack and play with the, and there are some heuristic rules. I'll come to that slide in a minute. There are some 3 basic principles we follow in the smoothing operation. And by doing that, we are reducing the flexibility, we're losing the flexibility we have from the slack. Increases the criticality of activities. This is another important. So these 2 are really important thing to consider. Criticality is activities will become critical once we do the smoothing operation. So a critical chain may not be a critical chain anymore. There can be multiple critical chain parallel to that original critical chain from the project network diagram. All right, so as I say, so the heuristic principle or the rule of thumb for scheduling resource, first of all, if we have multiple tasks from the activity network, which one will go first? Which activity we pick to complete? The one with the minimum slack, then smallest duration, then lowest activity number. 3 basic principles to look. So if we, from the project network diagram, if we have multiple activities but limited resource, which one will go first? It depends on, we look into the slack. The one with the minimum slack will go first, right? Then we have, if we have multiple activities with the similar slack, then the next rule is the one with smallest duration will go first. So what happens if we have multiple activities with similar slack and similar duration? Then the third rule is lowest activity identification number. So from the project network diagram, there is always an identification number. The lowest activity identification number will be loaded first onto the execution cycle. So 3 fundamental rule to apply the heuristics of scheduling resources. Any questions, please? No questions. Okay, so all good. I believe all you all got the point. The basic or the or three fundamental rule in scheduling resource. If we have multiple activities in the project network diagram, which one will be loaded to the execution phase? That depends on first of all, with minimum slack. So we look into, if you look into the activity details, right? This is activity number, early start, early finish, late start, late finish, duration, slack, right? So look into the slack. The activity minimum slack will be loaded first. If we have multiple activities with similar slack, then move to smallest duration. Look at the duration. If it is, if one is smaller than the other, smallest duration will go first. If it doesn't work, then look into the identification number. So that can be activity 1, 2, 3, 4, 5. With the list identification number, will go first. All right. So three fundamental rules for the heuristics we apply in scheduling resource. This is an iterative process. Iterative means we proceed with one step at a time. We reduce, we increase the early start date by 1 day and see the effect on the overall project. If that doesn't work, then we increase the early start by another 1 more day and look at the effect into the rest of the chain. This is an iterative process. We do not do it all at a time. In the next slide, you can see that this is a resource constrained project. We have a project network diagram of us that shows with the activity number and how much resource we need. This is an activity with we are limited by only 3 programmers. So at any time, we only have 3 programmers. So we need to complete the project with an available resource of 3 programmers. This is a very simple illustration of how we are really constrained by the available resource we have. Even though from the project network diagram, we have a clear understanding of the duration of the project, which is 14 days. Right, so entire duration is 14 days. But now, when the execution phase starts, now we got to know that we only have 3 programmers to finish the project. Now, if we start allocating the resource, we will see some problems in step 1, or say for example in activity 1, we need 2 programmers at a time. The duration is only 2 days. This is simple. There is no problem. So immediately we can start activity 1. We only need 2 programmers. We have the resource we need with the duration of 2 days. We finish it. That's fine. Once we finish it, from day 2, we can see early start of activity 2. We have 3 parallel activities, all 3 with early start date 2, right? And if we do the parallel activities simultaneously at the same time, how much resource we need? 2 to 1. So we need a total of 5 programmers to start the parallel task. All right. We need at a time, we need 5 programmers, but we are limited by only 3 programmers here. So we cannot we cannot start activity 2. That's right. We only have 3. We need 5. But so what are the activities that should be on the execution phase out of all 3? So activity 2, 3, and 4. Which one will go first? We only have 3 programmers. That's right. So that's why we are limited by resource. We cannot have all activities in the execution phase at the same time. So we now we need to know, we need to understand which activity will go first. So if we load activity, which one is the now if we apply the heuristics rule, which one is the rule number 1? Rule number 1 is lowest slack, right? So we look into all the slack. So we have a slack of 2, slack of 0, slack of 6. This is a critical activity. We have a 0 slack activity. So activity 3 should be loaded first. This should be in the execution phase. Immediately we allocate 2 programmers of activity 3, execution phase, done. Then we still have 1 programmer in 1 programmer remaining to be allocated. We have 2 activities, 2 and 4. But if we apply rule number 2, rule number 2 is what? Smallest duration. Right. So if we apply rule number 2, we can see that we have a duration of 6, we have a duration of 2. All right. So if we apply, which one is rule number 2? Rule number 2 is smallest duration. Then first of all, minimum slack. Then between 2 and 4, if we apply minimum slack, we can see for 4 we have slack of 2 is greater than, is smaller than slack of 4. If we apply rule number 1 between 2 and 4, this slack and this slack, if you compare rule number 1 is, if you apply rule number 1, then obviously 2 will, then again 2 will be needing 2 programmers at a time. So we do not have 2 programmers at, in our capacity to start activity 2, right? So that will limit us from. Could you show the previous slide? This one? Okay. All right. Now, so I repeat again, three rules for heuristics for resource allocation. Rule number 1, lowest slack. Rule number 2 is smallest duration, and rule number 3 is smaller ID number. All right. Now, activity 3 was very clear. Activity 3 was, it was an easy choice. Immediately we have 2 programmers needed with 0 slack that goes on execution phase. That's fine. Between 2 and 4, if we apply rule number 1 with lowest slack, we can see activity 2 has got lower slack of 2 days, but 4 has got slack of 6 days. But again, we are limited by resource. We need 2 programmers to load activity toward the execution cycle. So that will not help us to load. That means we go to the second rule. Second rule is smallest duration. If we look into both, we can see that activity 4 has the smallest duration of only 2 days, and it needs only 1 programmer. So we can load activity 4. So activity 4 will be loaded first. All right. So 3 and 4 will be parallel activity. So what happens to activity 2? What happens to activity 2? Is it not parallel anymore? Can anyone answer? So if we based on resource scheduling, now we know that we can move on with 3 and 4 parallelly. What happens to activity 2? Activity is not parallel anymore. So that means we can see from here the initial project network diagram will be changed. That's right. So we need to change the project network diagram. So initial project network diagram will be changing once we start scheduling the resource process. Okay, so so the real problem is now we know we can start this 2 days. At 2 days, this is the early finish. 6 days, the duration of 4. This will also be finishing in 4 days time, right? So we won't be having any programmer available until day 6. Okay, so that we need to wait until day 6 to free up these 2 programmers that can be allocated into task 2. So 2 will become a dependent task on 3 and 4. 2 is not a parallel activity anymore because of the limited resource we have. Now activity 2 must wait until 3 and 4 finishes. So 2 will become a dependent activity on 3. Once we can start, once we can free up this, then we allocate the resource we have. Then our early start time of activity 2 will be changing. This will change to 6 because we can't start before day 6. Okay, and early finish time, because of the duration, this is 6. This will be changing to 12. All right. So that means what? That means the entire project chain will be affected if we change the early start, early finish time. So that will be changed to 12. Then what about 5 and 6? Then 5 and 6 will be equally affected because of the resource we have. Once we start on day 6, activity 2 with 2 programmers, then we know that out of 5 and 6, which one has the lowest slack between 5 6 1. So activity 6 has the lowest slack of 0 days, needs 1 programmer. So we can start activity 6. So 5 will follow 6. So 5 must wait until 6 finishes. Okay. So now 5 is a dependent activity on 6. So once 6 is finished, then we can start 5. So the early start day of 5 will be changing. All right. So that means entire project diagram will be changing, and that the final project duration will also change. So this is the limitation we have when we start allocating the resource in the project network diagram. So that this is a one step moving forward in project execution process. So once we start the scheduling process, we will know more precisely about how many days we need to complete the project. So initial project network will change, the total duration of the project will change. There are some activities here, the slack will change, some will even move to negative slack. All right, so that will increase the criticality of each activities. So what are the steps that we do here in the resource smoothing process? So if you look at this table, this is a resource load chart. We call it early start resource loading chart, or in very simple word, this is in terms of weeks, number of weeks. All right, how much resource we need, how much resource load we need at each weeks or within each time frame. from 0 to 1, 2 to 5, 5, 4, 4, 4, 4. If we follow the original network diagram, we can see there are some activities with higher resource than we have in our capacity. These are the weeks that cannot follow the original project network diagram initially developed because of the limited resource we have. So we need to look into what? We need to look into these weeks and make smoothing operation. So an iteration process, as discussing on the previous slide, the very simple way of how do we apply the heuristic rule with lowest slack, smallest duration, and smaller activity ID. So if you look at here, these are the problem zone. These are the real problem zone. We cannot do it, right? We don't have the resource. So we need to alternative options of how we can do it. So from the previous slide, we can know that we can start 2 and 3 immediately, right? So we can start 3 and 4 immediately. Activity 2 must be shifted to 6. All right, so that must be shifted here. 1, 2, 3, 4, 5, 6. Okay, so if you start from day 2, 1, 2, 3, 4, 5, 6. So 2 must be because of the limited resource we have. All right, so if we do it, then what? Then at any time, if we don't have this number here anymore, then we are again pushing 5 because of pushing this one. So we have 2, 1. We have 3, 2, 1, 3, 2, 1, 3, 2, 1. We have 3. Then if we move it up here, once we finish this, 1, 1, 2, 1, 3, 2, 1. This is 3. Then this should be shifted because we do not have resource here. 1, 1. So the total project duration is now changed to 14 days. Is it clear? Okay. Okay, all right. Now let's see how we can do it in step-by-step process. So if this is a step-by-step process of what I just explained in a systematic way. Activity 1 is eligible for execution immediately. You're not restricted by any resource, so that can execute anytime. It requires only 2 programmers. That's good. We have 2 programmers in hand. Load activity 1 into schedule. That's fine. Then 2, 3, and 4. These are eligible to be scheduled. Activity 3 has the least slack. Apply rule number 1, which is the lowest slack with 0 slack. Load activity 3 onto the schedule. Then activity 2 is next to slack 2. However, 2 requires only 2 programmers. We only have 1. That means we are limited by the amount of programmers we have to load. We cannot do it. Delay activity 2, update ES to 3. Slack, now we have slack of 1. The next eligible activity 4, that requires 1 programmer. Load activity 4. All right. So this is now, so delay activity 4, that means this is a cross. We cannot start it after the end of week 2. We need to wait. But this is then early start will be changing to 3. Slack will be changing to 1. This is a step 1, but we are still limited by the resource. So we still cannot start the you still cannot start activity 2 until the end of week 6, right? So that means if we move on to the next step, we take 2, 3, 4, 5, early start day now 6, then early finish should be 12, so as late finish should be 12. And because early start is now 6, we have a negative slack of 2, right? If you look at the network diagram, we have a slack of 2, we have, this is 4. Now if we change this to 6, this is 4. Now we have a negative slack of 2. So slack can be negative. So that means we use the entire slack. We use all of the positive slack. It will be 0. And if you do not have any space, negative slack means that will increase the project duration. Negative slack will add to the total project duration. So we know. So what is the advantage of identifying negative slack from the beginning? That means from activity 2, if we know that there is a negative slack of, so the entire project will be delayed by 2 days. We are able to identify as soon as we start scheduling activity 2, we know that we are delayed by 2 days. The project duration will be extended by 2 days. So this is the advantage of identifying negative slack. All right. Then if we look at here, so that means we have now a negative slack of 2. We cannot start until the finish of day 6. We start from day 6, then we load activity 2 to programmers. That will be up to day 12, week 12. This is the new duration. Duration remains same, 6 weeks, but new finishing time for activity 2. Okay. All right. Now, so if you move to the next slide, so this is all. You can see that every single point is discussed as I've been just explaining. Then we now have 2 is eligible. Let's update activity 2 with early start 4 / 0. Still, we do not have the resource. 2 is eligible, but we do not have the programmer. Update ES5. Finishing time to 11 / -1. Still, we cannot do it. So update now. As soon as we have a negative slack, we need to update activity 7. So update activity 7 by 1 day, finish and negative slack time. So that means it's an iterative process, and the sooner the better. As soon as we can identify the project is delayed, let's update the very finishing task or the very last activity within the project chain by the appropriate numbers, so that we know exactly, the exact project completion time that is affected by altering early start date for any of those initial activities. Then activity 2 is eligible, but still we do not have the programmer, so make it to early start 6 slack of -2. Then again update activity 7 accordingly with early start and slack of -2. So the project is already delayed by 2 days. So if you follow the sequence of operation, that's how we end up with, and finally we will come to this point. As I said, this is an iterative process. This is an iterative process. We increase 1 day at a time. We don't do it everything in one go. We need to check, first of all, increase early start by 1 day, and what is the total effect on the entire project chain and the very last activity. All right, so that's how. So once we do a step-by-step sequential process, so then we check the other activities. We update the early start and slack, and accordingly we finish all the steps. This is the This is the modified or the final resource constraint schedule. Now we know that we need 14 weeks. Okay, so if you look at, so if 13 slack to be -1, yes, so there will be negative slack. There will be negative slack in some of the activities once we identify the limitation we have. There will be negative slack, yes. There will be negative slack in activity 2, -2, this is a negative slack. We have a negative slack of -2 in activity 7 as well. This is a negative slack. This is a negative slack, and this is a negative slack. But it's actually, it's written wrong, I guess. What's wrong in here? Can you explain? Previous slide. Here. Activity 4, 5. Yeah. Delay activity 7, update ES, slack of -1. That's right. Should be 12. No, ES for activity 7 was initially it was 10 days. Okay, so initially it was 10 days. Now that we delayed the project by 1 day, so that should be updated to 11 days, and there will be a slack of -1. This is the slack. Our early start minus late finish is the slack. You can turn on your voice if you try to explain, if you need to explain. You can unmute yourself.
Sir, in activity 7, like early start is if it becomes 11, and early finish as described in that slide. Then it will come to be -1, but it's written like it's early finish to be 13. Then if we click early finish to be 13, then 13 minus it becomes -2 and not -1. So that's what I was confused.
Sorry, in activity 7, early start 11. This is late finish 13. This is not early finish. This is late finish. So that means we updated the project is delayed by 1 day, so the late finish should be updated. This is a slack of -1. What's wrong? What's wrong here? Here? Okay. This is actually late finish. This is actually the duration of the project. So that means we are This is the late finish. So that should be updated to 13 days. Okay. Okay. All right. This is done. This is done. This is done. Done. Any other questions? No questions. So crystal clear. Let's move on. Then once we are at this step, the final resource constraint schedule, we need to update the earliest and late finish time and identify the new project duration of from the resource constraint schedule and update the network diagram accordingly. So you can see that a lot of the numbers are now changed. Activity 1 is this is as we planned. It remains same as 2, but this one is now starting time 6, early start time 6. All right, with early start time 6. Now this then activity 6 will begin before activity 5. Activity 5 can have to wait until day 10. Then the earliest start time for activity 7 is 12 days. This is 14. And the entire project network diagram is updated accordingly. So once we have the new resource schedule network, you can see that we have now 0, 0, 0, 0, 0. So this is the updated version of the project network diagram. That means we know that yes, there are the negative slacks, but once we update it with the new finish time, new project completion time with 14 days, a lot of the activities will become critical. Okay, so in the previous project network diagram, we only had one critical chain, one critical activity, but now we have we have 1, 2, 3, 4, 5 critical activities, 5 or 6 critical activities that we cannot change, we cannot alter. So criticality of the activity will increase. It will we'll have to be more careful in process as how we load each of the activity into the execution phase. Okay, impact of resource constraint. The impact of resource constraint scheduling process. It reduces slack. That means, as you just saw, so a number of activities will become 0 slack. Okay, activities with 0 slack will be increases the criticality of event. Then it increases the scheduling complexity. Now that we have a number of activities with 0 slack, we need to maintain that duration. If by any chance one activity is delayed, that will affect the entire project chain. Make the traditional critical path no longer meaningful. This is another clear statement. That means the additional, the initial critical path may not exist anymore. There will be more critical path alongside with the original critical path. Can break sequence of events, may cause parallel activities to become sequential. All right, you all have seen from the previous example, parallel activity may not exist as parallel, so it can be a sequential activity, and activities with slack may become critical. So we had slack of what? We had slack of 2 days, 6 days. We had some slack here, but when we have the final version of constraint schedule, we know that all of those activities become now have 0 slack. All right. Any questions, please? Okay. Next is splitting process. Splitting is splitting process. In the next step, we will see some activities that we can. Now we are moving into more and more complex optimization process. So splitting is an optimization process. Chance to split a specific task in the project network chain. We can split, but remember in the previous example we mentioned about we cannot split, right? In the resource leveling or smoothing process, we mentioned that one of the assumptions is splitting is not allowed. However, here, if we now that we have a resource constraint project network diagram, we can see at some step there will be some resource that are sitting idle. All right. Say for example, in the previous chain, you can see that once we finish this, once this is finished, then really this is a slack, or one programmer is not, it's not doing anything. So this is an idle time. Okay, so we need to make sure that at every step of every time phase, we are maximizing the resource we have. So in the next step, it will become really, really complex once we start the splitting process. But in simple word, what is splitting is it is dividing any activity into multiple sections with easy start and easy stop and easy start. So we can't pick any activity from the network chain. So that has to be suitable for splitting process. So that can be, the splitting operation can be done only to those activities that are suitable for splitting. So this is a scheduling technique for creating better project schedule or increase the resource utilization. I would say this is maximizing the resource utilization process. We don't want any resource to sit idle and do nothing. We want to make sure that every single time that whatever we have, we are 100% we are utilizing it. It involves interacting work on an activity to employ the resource or another activity. So then returning so we need to, as I said, we need to stop it, take the resource out of that activity, use it in other activity, then bring back to original activity where it stopped. So there should be a clear stop and start point, even though we are splitting one big activity, but the smaller fraction should have a clear stop and start point. So it's only feasible when startup and shutdown costs are low with the minimum impact on the overall project. If you can do it, that's fine. It is considered a major reason why project failed to meet schedule. But remember that it can impose some risk to the overall project completion. Excuse me. It can impose some risk on the overall project execution process. Say for example, if the stop and start process is not smooth enough, if you cannot start exactly where you stopped, that will create some additional problem. Without activity duration, without splitting, no interruption at all, we can straight away, you can finish it once you start. If we want a stop, start, or if you want to split the activities, activity A, B, and C, we can see that there is a shutdown time and the restart time. Shutdown time and the restart time. So the overall duration may increase due to that shutdown and restarting process. So that's one thing to consider. What are the benefits of um, um, benefits of resource scheduling? I would say the list goes on and on, but most importantly, the time cost trade-off that we within the budget and time we have, how we are trading off the resource and the change in priorities. Then also provide information on the time phase budget development. So this is from the beginning of the lecture. I mentioned about we'll see how we can start forming the time phase budget. So from the resource scheduling perspective, yes. Do you have any questions? Any questions? Okay. So if we move on, then these are the slides with multi-project resource scheduling. Why we need multi-project resource? What are the problems with multi-project resource scheduling process? That means we need to allocate the same amount of resource across multiple different projects. So that is a very complex task in terms of how you need to liaise with a number of project manager and make a consolidated list of resource requirement for each of those projects. It can have the main problems are overall project. It can, it may not finish on time. Insufficient resource application, resource bottleneck. That means at any point of time we'll be really constrained if we try to allocate similar resource to multiple different projects. It can be really problematic when it comes to allocating resource into multiple different projects. In the next slide, you can see that how we can manage multi-project scheduling problems. So these are some key or fundamental rules, but overall, it is a very delicate task. Create project office or departments to oversee the scheduling of resource across different projects. There should be a clear communication, very strong, and regular communication among the project managers in terms of what resources they need in what time frame. Use of project priority queuing system, so a consolidated central system that every project manager can see which in terms of their activity, what they need in what time, or they can be first come first serve basis on the resource. A centralized project management system, as I said, and outcome and outsourcing project to reduce the number of projects handled internally. Another effective way is how we can get out of that multi-project scheduling problem is outsource some of the projects to external parties so that we have less number of projects to handle internally, if we have the option to do so, obviously. All right, in the second part of the lecture, using the resource schedule to develop a project cost baseline, or we also call it a time phase budget baseline. Time phase budget baseline. Now, before I start that, I want to give a pause for 5 minutes and ask any questions that you may have. You can unmute yourself, or you can also type on the chat window. Any questions, please? No questions. All right. So how about the online delivery of units? Are you finding it useful, or obviously it's not as effective as a face-to-face lecture, but it's still you have some work to do. All right. Any questions on the case studies? Clarify submission date of case study. This is 17th of April. Marking criteria, there is 5 marks, 2.5 for each question. Professionalism, clean and tidy presentation, these are all for master's level. We should not advise you on these aspects. So these are the things that you should have learned long ago in your undergraduate. Is there any minimum word limit for the answer? There is no minimum word limit, no. Post date, submission 12, please ignore that. I'll update that into the system. Ignore the post date. All answer can be found in cases, that's right. You should only prepare the answer, whatever is written in those, in the case study description, yes. Thank you. Shall I continue again? Because you don't have the midterm test anymore, and also you have 30% of the group project, which is like you can work in teams, and that will be a major assessment task. 30%. Case studies, these are real life case studies. These are from Harvard Business School, and based on real industry case scenarios. So if you read more and more, you get to know a lot more about the project management aspect from industrial perspective. So and 4 is, I mean, I think this is, we should not even, you know, try to reduce the number. 4 is the absolute minimum. You must do at least 4 case studies. When we'll start group working? So this is end of week. This is the beginning of week 5. I mentioned in my announcement that you should start forming your groups by end of week 6, and your group project question assignment will be released by at least by end of week 7. You have to submit by week 13. Week 13, or I can extend the deadline on up to week 14. We need to finish a number of tools and techniques. Project network diagram, earned value. In the next week's lecture, there will be some more mathematical terms. We need to finish it before you can even start on your group project. So you need to understand the fundamental of project management, all the mathematical terms, tools, and techniques. Then you can start working on your group project. So that's why it is after the midterm, you can start working on the group project, possibly starting from week 8. Will there be some leniency while assessment as we now have online classes. What do you want me to do? Pass everyone? The number of slides per unit is per lecture is too much. This is because there are a number of example problems. So these are here to help you understand the topic. If you look at lecture 6, I think at least 10, 15 slides out of 50 is example problems and solution. So I can remove that if you don't want, but I thought this will help you to understand the topic better. You will have there will be a lot of leniency because it is not as face-to-face offering. The examination process and everything will not be as hard as a face-to-face offering. So you all will be benefited from this online offering. I will upload the lecture video. Okay. All right. We hope so. We hope the situation gets will be normal as soon as possible. Case B4 say Jada Leni Sakte. But I'm sorry, I didn't get it. Sorry. One of the challenges we are facing is the group work given that we are not able to make. Online communication sometimes is still a challenge for us. Any tip or suggestions on this? Look at me, what I'm facing now. Look at me, I have a team of 6 PhD students, 1 postdoc, 3 tutors. I'm teaching 2 units in this semester and everything sitting here. So I cannot go to office. This is the situation that I couldn't imagine at least a month ago, and I have to do it. Since we received the email from the Vice Chancellor, everything will be moved to online, and within 2 weeks we adapted to this change. So I'm meeting all my PhD students through online, my postdoc through online, my tutors through online. I'm meeting a big class such as you of 110 students online. You can meet, you can talk. The most important thing is as soon as you have the group project, you will be allocating tasks. So all of you should not do the same task. So there will be at least 5, 6, or 7, or 8 different aspects of the group project, 8 different questions, 8 different tasks that you need to do. So as a group leader, there should be a group leader for each of those groups. The group leader should allocate specific tasks to each of the group members that you must complete this. And let's aim to meet every week at this specific time on Zoom. Let's discuss how we are progressing, and make sure that the task developed or done by one of the group members is obviously being checked by other group members, so that you are happy, right? Because it will be affected if a poor submission, a poor delivery of specific task is being submitted with the overall group project. So your job is to make sure that all the work that you are submitting is maintains quality. We can meet on Zoom also. Yes. How many case studies? will be there in group task. Group task will not be based on case study. Group task will be based on a real life project proposal development scenario. There will be multiple tasks, yes. You can also meet on Zoom. You can also meet me on Zoom, or you can meet with your group mates and team, other members of the group on Zoom. You have access to Zoom. The problem with group is we haven't had the chance of knowing other students properly. It is a bit difficult to select group members. If you don't have your own group, I will allocate randomly and then you introduce yourself. We are continuing the group for this unit is fine. We are 5 members. Yes, that's fine. Any other time you'll be available on Zoom for communication other than Mondays? I am. Well, drop me an email when you need to discuss with me. I'll be available through Zoom. How about those that have groups already? You can continue on your existing group. 4 to 5% in each group. Three, no. You need a minimum of 4. Give me a link to divide the group on island. There will be a link to submit group proposal, yes. If you do not know anyone else in the unit, I will allocate you to randomly to any of the groups. Then you introduce yourself, start working. I will advise how you can submit your group member's name. Those, as I said, I mean, if you do not have a group, I will do my best to randomly allocate you to one of the groups. Okay. All right, now let's. Okay, now let's get back to our lecture. So the next topic is how we can form the time-phased budget baseline. This is from the original budget estimation. Time-phased budget is a bit advanced level estimation in the project management process. It deals with the each of the activity, how much budget we need for each of those activity, and by this time you already know the schedule of those activities in terms of the number of weeks when the activity will be loaded on the execution table. So and if we can have a time-phased budget, that means how much money we need from the time-phased budget. That will really help us in overall cost management process. How can we create, assign each work package to one responsible person or department, and then compare plan, schedule, and cost using an integrative system we call earned value. Earned value is a very important element we will discuss in the next in the next lecture. The very first step of earned value technique is start creating the time-phased budget. So time-phased budget will give us critical information in many different ways. So let's move on. Let's see how we can start forming the time-phased budget. In very simple word, if we have a project of the total budget, we divide it into 3 work breakdown structure. Then from here, we divide it into sub-deliverables or sub-tasks. From here, we can know that we have a budget of, say, for example, for the design, we have a budget of 600,000, right? So how do we divide this? Across what time frame we can use the money? So from the design team, we know that what we have. So if you look into the, if you look at how the project is structured, we have the design, production, test, purchasing, and software development. All right, and all of these are part of what? So design and production is part of the manufacturing process, and that you know in the this is again part of what? Part of the hard disk design and development process. So out of that 1600 budget, we need to allocate how we can time phase the amount of money we have in this design process. So I mean, if we allocate the funds accordingly for design, production, and testing, right? So we can from the work breakdown structure, we can again subdivide the total amount of cost that each work package needs in the design process. All right. Same goes for the production, testing, purchasing, and software. So these are all breakdown of the total amount of money we need in different stages of the work breakdown package. If we go to the next slide, this is, I'm going to skip this. So if we go to the next slide here, so this is the project network diagram we have for any project. We know the early start time, early finish time, then the amount of slack here, all information we have, including the duration. Okay. Now, if we start forming the time phase budget for this project, all right, you can see the total amount of budget we have, all right, and across each time phase, how much money we need. From 0, 1, 2, 3, 4, 5, 6, it goes up to the entire duration of the project. This is a very simple process of dividing the total amount of money we have in across number of weeks. All right, so that we know exactly that if we form the cumulative budget, we know exactly how much money we need for those activities, and in terms of the total budget of the project. So if you look into how much money we already allocated, we will also have an understanding of what phase the project is currently in. How many weeks have gone? All right. So cumulative budget or time phased, or in other words, budget that is closely related to timing of the project. That is a time-phased budget. Now, these are arbitrary numbers. There is no hard and fast rule. It depends on the project manager and the project team. They should already have an understanding of how much money it can take for each of those activities here. There is no specific format, no specific rules to apply. This depends on the estimation team. It is up to them about how the estimation is done for each of those activities, and that can be related to the duration of the project activity, which is known as the time-phased budget. All right. Now that is any questions about the time-phased budget? Very simple illustration, very simple process, and then you add up all, you put the numbers for the cumulative one, plot the graph, then you have the total graph of the time phase budget estimation. Very simple but effective. If we look into the total amount of money spent, we know the status of the project, how much, I mean, in terms of how many weeks have gone, what activities have been finished already. So that is all for today's lecture. Now there are five or six class activities that you see from here. Have you practiced the activity from last week's lecture? Any confusion on that part? Yes or no? There are 1, 2, 3, 4 class activities, including the social event. So please have a look. Please have a look at the class activities and discuss with me if you have any confusions. If we discuss activity 4, so given the time phase budget work, complete the baseline budget for the project here. So you can see that the project network diagram is given, and cost by week is already being developed by the project estimation team. These are activity details and how much cost they need for each of the weeks. All right, so from the information given here, we need to build a time phase budget or a cumulative budget. All right, very simple. Once you have the activity details and project network diagram, you know activity ID, early start 0, early finish 4, you need 10,000 for each week. So put the numbers accordingly here. Activity B, again, early start 0, activity B, total budget of 32, number of weeks given, put the numbers in here, okay. Then activity C, with an early start of 4, let's activity C, early start 4 here, the budget is given, put the budget back in here, all right, proceed like that, add up all, then you have a cumulative budget. All right, then you can plot a graph of the total number of weeks. Dollar value, simple. Activity 3 is this one is with the resource scheduling process. So you have to compare the following schedule for a project in which the key resources is a tractor. There are 3 tractors available to the project. Activity A, D require 1 tractor to complete, and B, C, E, F 2 tractors. All right, so we are limited by the number of tractors we have. This is maybe a civil construction project. We know how many tractors we have and at what time we can do what. So a resource scheduling process. Develop a resource constraint schedule depending on the limited resource we have. This is exactly the same problem as we discussed in the lecture. So how we have to delay the early start time and how it will affect the overall project duration. All right, please have a look. Have a look at all the class activities and let me know if you have any confusion or any questions. Now I will open to open for any questions that you may have. That's all for lecture 6. No questions? Okay, then I will stop. Can I stop the meeting now?